Okay, number 9 on the test 1 review. It says, if possible, find one value of c that would result in the equation having no solution. So the first thing that would be helpful is to simplify this equation down. So we can distribute 2 times 4x is 8x. 2 times c is 2c equals 8x plus 6. And I can keep going. Okay, the x is on the same side of the street. So subtract 8x, subtract 8x, 0 here, and I also have 0 here, and I'm left with just 2c. The x's are completely gone, and I have just 2c equal to 6. If I divide out the 2 on both sides, c ends up equaling 3. What that means, though, if c were the value of 3, what we really did here was we really made both sides exactly equal. If that's a 3, then both sides are 8x plus 6. Both sides. That means if I were to graph this, both equations are 8x plus 6. And if I graph that, I get one line, and so there'd be infinite solutions. In this case, I want no solution. Therefore, if I make this value something other than 3, so let's say I were to have 2 and then 4x plus 1. I'd have 8x plus 2 after I distribute, and that would leave me with one of these equations being 8x plus 2 when I go to graph. If I were to graph those lines now, I have one line at 2, and I got the other one at 6. Those lines are parallel, or they would not have any solution in common. They are different. Now, these two are different. They are not equal, and they could never be equal. Because if you go through this now and you've got 8x plus 2 equals 8x plus 6, well, I subtract out 8x, and I have 2 equal to 6. And that's not true. 2 cannot equal 6. So in this case, if I want no solution, all I have to say is all values but or except the number 3. Right? Because we put in a 1 there, and that made it so that 2 was equal to 6, which we know is not true. So any value besides the number 3 is going to give you a number not equal to 6. Okay, part 2, if possible, find one value of c that would result in the equation having infinitely many solutions. So that is what we did here, right? If it's 3, then both sides are 8x plus 6, exactly. And that would give us infinitely many solutions. So we have c is 3. If possible, find one value of c that would result in the equation having exactly one solution. Well, we went through the equation, right? So we got 8x plus 2c equals 8x plus 6. Notice that the 8x, if I subtract those out, they're going to drop out every time, no matter what the value of c is. Our x's are going to disappear no matter what the value of c is. If the x's are gone completely, we're either going to end up with no solution or infinitely many. So in this problem, there is no value that would give one solution. It cannot happen. There's no possible value that will make that happen. Number 10, the owner of Fiesta Fun Center wants to know how many customers to expect at any given time. Notice that it says he wants to know how many customers. So right away, look at C where it says which quantity would be most useful. Well, part C says the amount of money earned. You don't want to know the amount of money. He wants to know how many customers. So C is gone. You don't need that. That's out. Okay. The top one says the average number of customers playing mini golf. Well, yeah, that'd be great to know how many are playing mini golf, but there's other people there too. And he wants to know how many customers to expect at Fiesta Fun Center, the whole entire place. So if it's just mini golf, well, that's not good enough. The next one, average number of customers during the morning, bowling. I mean, so that's not any given time. That's in the morning, and it's only giving us the bowling, people who are bowling. So the last one says average number of customers entering the building per half hour. Well, there you go. You got how many people are coming in on average to the building itself every hour. That's got to be the most helpful quantity that we could come out with. Next one, create an expression that models the cost of buying and running a refrigerator. Purchase price of $1,800. I only have to pay that $1,800 one time. So keep that in mind. Also, it says expression. Expression is not an equation. There's no equal sign. So in this case, I can just start by writing 1,800. I have only one 1,800, so there's no variable next to it. And it costs 80 cents a day to operate. So 80 cents is going to, if I have one day, that's 80 cents. 2 days, another 80 cents. 3 days, another 80 cents. So because it's going to repeat that 80 cents, and we don't know how many times, repeated addition is multiplication. So in this one, we know it costs $1,800 plus, you got to get the total cost here, 80 cents to run it every day. And here we don't know how many days, but we do know that that's going to multiply with how many days. So, and we can call the number of days x. And that would give us an expression right there. There's no equal sign in there. That's our expression. Next one. Disneyland, they've got $200 already. $200. They've got that. They need at least 500. That means they need to get 500. They can equal 500, or they're going to need more than 500. I need at least $20 to go to the movies. That means I need $20 or more. Next, if she makes $14 an hour, write and solve an inequality that describes the number of hours she'll need to work in order to buy a souvenir while she's there. And then we're going to graph. So she's making $14 every hour. She's already got her 200. So she's going to add on her $14 she's making every hour. 14, 14, 14, 14. Going to repeat that. Therefore, we have to have a variable on there. If you want to put an H for hours, feel free, because that's what we're representing. And then we solve this inequality. Similar to an equation, so we got 14x greater than or equal to 300. Divide out 14, which leaves us with a decimal of 21.43 if you round it. So x is greater than 21.43, and we're talking about hours. They have to work that many hours or more to be able to, what are they doing? Go to Disneyland. So we're going to mark, let's put this will be 20. This one here is going to be 21. This will be 22. This will be 23. And we're going to mark 21.43. So 21. Here's halfway, a little less than halfway. I am going to fill in my circle. So there's my 21.43. I fill it in because it's got the line. The line means we can equal 21.43, that big long decimal, or we can be more. So I put my dot, fill it in, because we can equal, or we can be more, so shade it also to the right. Next one, a proportion. So we're going to cross multiply, because when there's an equal in between two fractions, we can cross multiply. We're going to have, I'm going to do -3 times the 4m minus 2 first. We set the two equal to each other. So I've got that crossed, equal to -5 multiplied with the other side, 3m plus 6. And now we solve it just like a normal equation. Distribute, -12m plus 6 equals -15m subtract 30. And then from here, we can add 15 over, or we can add 12m. It doesn't matter. And I'm writing on top of words. Hope you can still see this. You got 0 there. You got 3m here. Plus 6 equals -30. Subtract 6. And you got 3m equals -36. And divide out 3. So last of all, m is -12 is the answer. Next one, number 15. Or 14, sorry. I think I've got this one on the next. Nope. I'm going to do it on this page. To wash a load of laundry, it costs $6.50 for the washing, plus an additional charge of 20 cents a load. So it's $6.50 plus 20 cents a load. It's every load, 20, 20, 20. You don't know how many there are, so you got to have a variable. A dryer costs $8.50 or $5.80 with an additional charge of 35 cents per load. Create an equation that represents the total cost of washing and drying the same number of loads. Notice it's the total. So in this case, here's the cost of washing, and then the cost of drying, well, it costs $5.80 for the dryer and 35 cents a load. So the total cost, the equation I'm going to write down here, we're going to have total cost, C is going to equal, well, I'm going to add my two together because I want the total cost here. So it's going to be $1,230 for both the dryer and washer, and then the price of running the machines. Each load is 55 cents for both machines. So that's our total cost. Just add them straight down together. Next one, number 15. A computer technician tells Autumn that it will cost no more than $150 to fix her computer. The parts cost $80 and they charge $25 an hour. So they know they're going to get charged $80 for the parts. And she also knows she's going to get charged $25 an hour. This is how much money she's being charged, $25 an hour. And the technician told her that it'll cost no more than $150 to fix. So no more than. So this is her cost, and it's not going to be more than $150. So it has to be less than or equal. It can still be equal without being more. So it's just not more, but it could equal. And then we can go ahead and solve this.